Good evening. Welcome to lecture 11 of Thermodynamics course by NPTEL. So, this week we will be solving revision questions and assignment questions from week 10. So, we'll start with the first question. These are revision questions. First question: write the definition of humidity ratio, also known as moisture content. So, humidity ratio or specific humidity, okay, is the mass of water vapor per mass of dry air. So, water vapor by mass of dry air. Okay. Next, why is moisture content uh, calculated on the basis of dry air mass and not moist air mass? Okay. So, because dry air is the main component and it doesn't change, whereas moist air includes the water vapor and that is what is varying. So using dry air as a reference makes calculation consistent. Okay, that's why we are using moist air. Next, consider moist air at a certain state, say 38 degrees centigrade DVT and 50% relative humidity. It is desired to take this mixture to its VBT. Okay, dry bulb temperature and wet bulb temperature. Can this be accomplished without adding or removing moisture from the air? So, um, to reach WBT without adding or removing moisture, that is a question. So, adiabatic saturation process, if we are recalling that, we will understand if you cool the air adiabatically by evaporating water, the WBT is achieved without adding moisture. Do you think so? No, you add moisture through evaporation, right? So, without adding or removing moisture is not a possibility because to reach WBT, you usually need to add moisture via adiabatic cooling. Okay, so the answer would be no. Now, is it possible to attain dew point state without cooling? So, dew point is when you cool the air at constant pressure until saturation. So, without cooling, maybe compression is one way to look at it. But again, compression would increase temperature. So, alternatively, um, we have to think only another possibility, which is mixing with cold air. Again, it is cooling only. So, answer is no. Now, in problem 10.3, dry cold air at negative 10 degree is added to the air. Is it possible to saturate the air in this manner? So, fifth question, they are saying this. So, adding dry cold air at negative 10 degrees centigrade to a 38 degrees centigrade air. So, mixing two air streams is the question over here. So the resulting temperature would be somewhere in between. But since cold air is dry, adding dry air would lower the moisture content. So probably not. It won't. It would decrease the humidity ratio, making saturation less likely. So again, the answer is no. Okay. Next is fill water in an ice tray and place it in a freezer. Observe the amount of ice in it every 24 hours. What do you observe? Write an explanation for this observation. Okay. So ice tray, observing ice over 24 hours. If you're seeing that freezer is below 0 degree centigrade or at 0 degree centigrade. Um, but if the freezer has a defrost cycle or something, it will sublimate, right? Ice will sublimate. Now, they are talking about fill water in an ice tray and place it in a freezer, right? So, uh, normally water freezes into ice, but over time, maybe ice can sublimate because freezer air is dry. So, after 24 hours, maybe the ice cubes get smaller. Okay. So, sublimation happens due to low humidity in freezer. Next is what type of process are denoted by a vertical line on a psychometric chart? So, vertical line on this chart are constant humidity ratio. Okay. Okay. So, constant humidity ratio, that is sensible heating or cooling. So, processes where only temperature changes, not the moisture content. That is the vertical line. Now, a chamber contains moist air at 85 degrees centigrade and 90% relative humidity. Write the equations using which the moisture content can be calculated. So, moist air at 85 degrees centigrade and 90% RH. Equations, we have to use the formula. Okay. So, this is right. Omega equal to 0.622 times PV by P minus PV. So PV equal to 5 times Psat at the given temperature. So you have to find this Psat from steam tables and then find omega. What is meant by adiabatic saturation of air? So adiabatic saturation of air means it's a process where air is cooled and humidified adiabatically by evaporating water. By that process, it will reach the wet bulb temperature. The enthalpy is going to be constant. That is why it is called adiabatic. Okay. Next is it possible to increase the dBT of moist air by addition of water? So increasing dBT by adding water. So adding water is like evaporative cooling. So evaporative cooling usually lowers dBT. Uh, so then if water is added at a high temperature, then dBT can increase. Okay. So adding steam can increase both moisture and temperature. So dBT will be higher. Next is moist air flows through a nozzle where its velocity increases and pressure decreases. What happens to the temperature? Show the process on the psychrometric chart. Okay. So air through a nozzle, velocity is going to be increasing and pressure is going to decrease. So for ideal gas in a nozzle, usually the process is isentropic. Temperature drops. So moist air means if temperature is also dropping, then in psychometric chart, it can be a constant WBT process. Okay. So it will be like a horizontal line uh, from right to left. Cooling and constant humidity ratio. that is going to be there. Then next one, estimate the temperature and RH of air exhaled by a person. How can one estimate the enthalpy change in the breathing process? So exhaled air temperature will be like our human body temperature with high RH, like around 100 percentage of relative humidity will be there. So enthalpy change will be the temperature difference between inhaled room and exhaled body. Okay, so body temperature to room temperature, that will be the enthalpy variation. Write the relation for moist air enthalpy in terms of dry air and water property. Okay, so moist air enthalpy will be like H equal to H dry air plus W H will be there, where dry air enthalpy is to be found by Cp of dry air times temperature, and water vapor enthalpy will be Cp of water times temperature plus HFG. Okay, that is how you will be finding it. I'll write it over here. H equal to H dry air plus W times HW. So H dry air equal to Cp times T, and HW equal to Cp times T plus HFG. What is the difference between specific humidity and humidity ratio? Specific humidity means kilogram moisture per kilogram moist air. Okay, and humidity ratio is kilogram moisture per kilogram dry air. So different definition, one is moist air and another is dry air. Then next is air below. Okay, when air temperature is below 0 degrees centigrade, then it cannot hold any water vapor. Comment on this. So air below 0 degrees centigrade can't hold water vapor. That is incorrect. Air can hold water vapor as long as the partial pressure is below saturation. So even below 0 degrees centigrade, ice can sublimate, which we have seen earlier. So statement is wrong, false or incorrect. Okay, next is what is sensible heating of moist air? Show the process on the psychrometric chart. So sensible heating is heating without changing moisture content. So in a psychrometric chart, it will be horizontal line to the right. So increasing dBT, same W. Okay, that is how it will be. Then during sensible heating of moist air, both specific humidity and moisture content remain unaffected. Comment on the correctness of this statement. Okay, so during sensible heating, specific humidity and moisture content is same. Uh, that is what is the sentence given. Since no moisture is added or removed, humidity ratio remains same. So specific humidity, if it is defined per moist air content, it would change slightly since temperature has changed, but mass ratio is going to remain the same. So statement is correct. Now consider the statement: in an evaporative cooler, the air is cooled and so is the water. This means there is violation of the second law of thermodynamics. What is your view? Okay, so evaporative cooler cools air and water. Uh, that that violates second law of thermodynamics or not? That is the question. So the cooling which is achieved in the system is achieved by evaporation, which requires latent heat from air. So entropy is going to increase. Like any heat addition, entropy is going to increase. So no violation is there. Okay. Now, will a mixture of methane gas and water vapor behave like moist air? So moist air is dry air plus water vapor. That is N2O2, CO2. All this will be there, and water vapor is also there. Methane is a different gas. So uh, methane, if it is showing its ideal behavior, so uh, the methane plus water vapor is going to be an ideal mixture, then for some purpose maybe we can take it as a moist air kind of system. Next is 10.20p, compressed air. Okay, ambient air is compressed and stored in a tank where it cools to ambient temperature. This system is needed for air breaks. It is observed that moisture condenses in the reservoir. Thus, at the higher pressure and same temperature, moisture condenses. Write equations and reasoning for this behavior. So, compressed air, when it is stored, the moisture condenses inside the system. At high pressure, the vapor pressure at saturation is lower. So when compressed, what is happening is the partial pressure of water increases, and if it exceeds the saturation pressure at the temperature at which it is stored, condensation is going to occur. So equation is PV equal to 5 times P saturation at the given temperature. Okay, so PV equal to 5 times P sat at the given temperature. Okay. So after compression, what will happen is this PV is going to be uh, greater than P of saturation at the given temperature, so that condensation will occur. Now, in the process of an adiabatic saturator, does the entropy increase? So, adiabatic saturator entropy, since it's adiabatic, uh, but it is going to be irreversible because mixing and evaporation, those things are happening. So entropy is going to increase. So entropy of mixing is there. In the previous assignment also we have seen questions with en- entropy of mixing involved. Now next is fogging on. During monsoon and in winter, vehicles experience fogging of windows and windshield. Why does it occur, and under what condition does this occur? So fogging on windows occurs when window temperature is below dew point of interior air. So moisture is condensing on the cold surface, that is the window. Now it is common in winter when warm, humid indoor air hits the cold window. Okay. In very dry weather, humidifiers are used. How do they add moisture? So humidifiers in dry winter, they add moisture by evaporating water using ultrasonic, steam, or evaporative methods. Next is what DBT and RH would you recommend for an astronaut suit? So uh, the comfortable temperature that we consider is around 21 degrees centigrade, and moderate RH around 30 to 40 percentage of relative humidity. That is what is required for life support. At what pressure and temperature combination would an atmosphere of helium and methane behave like moist air in Earth's atmosphere? So helium and methane atmosphere behaving like moist air, that is what we want. So here similar behavior has a condensable component like methane as vapor with possible liquid or solid phase. So at a certain pressure and temperature where methane can condense, it is going to act like water. Okay, so water, how water is acting like uh, the moisture content in the air, just like that, methane is going to condense and act like the moisture addition to the atmosphere in Neptune at the pressure and temperature where methane is going to condense. Next is on the web, look up instruments for measuring dBT, WBT, and dew point. Okay, so dBT, we can use thermometer. This is also thermometer only, wet bulb thermometer. Then dew point, you have got hygrometer. Hygro means like related to humidity, water content, etc. Under what condition will air inside a refrigerator be less humid than that outside? So, fridge air to become less humid. When air is cooled, the capacity to hold moisture will decrease in that for that air. Okay, for that volume of air. So, if cooled below dew point, moisture is going to condense. So, then the fridge air is having lower humidity. Next is which of the following properties of humid air fully specify the state? The pressure is there, dBT, RH, then so there are a lot of combinations are there. So what we have learned earlier is to specify state we need two independent properties. So first one is pressure, dBT and RH. So pressure and dBT is temperature, yes. So um, that is a possibility. Second is pressure, WBT, and humidity ratio. Yes, that is also a possibility. Then third is pressure, WBT, and humidity. Yes, that is also a possibility. Then the second one is pressure, specific enthalpy, and dBT. So specific enthalpy is dependent on pressure. So that is a redundancy, right? So that is not a possibility. Then dBT, WBT, and humidity ratio. Again, dBT and WBT are temperature variables. So again, redundancy. Then the next one is specific humidity, humidity ratio in RH. Again, redundancy is there. So those three are not applicable. D, C, and F. A, B, and okay, two B's are there here. So these three are the possible combinations. Next is it possible to produce an equilibrium mixture of dry air, saturated liquid vapor, and saturated liquid droplets at 1 bar pressure? So equilibrium mixture of dry air, saturated vapor, and droplets. So that sounds like a triple point, right? But the thing is, triple point is only for pure substance. Now we are talking about the mixture of substance. So for moist air at saturation, we'll be having vapor and liquid. So at 1 bar, if uh, if cool to dew point, then yes, we can see this thing. Okay. The flue gas of a furnace contains the products of the following combustion reaction at 90 degrees centigrade at ambient pressure. Traces of SO2 are also present in the gas, as also traces of NO. In order to prevent precipitation, which will be precipitation of sulfuric acid and nitric acid, which severely damages the steel components that are in contact with this gas, the temperature should be above the dew point. How will you calculate the dew point of this mixture? Note that besides water vapor, the remaining constituents do not have the composition as dry air. Okay. So, dew point of flue gas, it is like H2O is there, SO2 is there, NO is there. Okay, these are the combination. So, dew point is the temperature where partial pressure of water equals saturation pressure. But presence of other vapors like sulfuric acid or HNO3 would lower the dew point. Now we need to, that is what is given here. Besides water vapor, the remaining constituents do not have composition as dry air. Okay, so uh, so we need to consider the partial pressure of all condensable species. So acid dew point is higher than water dew point, that you have to keep in mind. Okay, then we have to calculate for different species what are the dew point and when will it get condensed. Then accordingly we will be calculating the dew point of the mixture. Next. Okay, this is using the table we have to do. We'll go for the second question. A sling psychrometer is used to measure the room temperature. Room dimensions are 4 by 5 meter and 3 meter high. It is empty. The psychrometer showed 36 degrees centigrade and 24 degrees centigrade as dry and wet bulb temperature respectively. The ambient pressure is 95 kilopascal. Now we have to calculate a couple of things. Okay. Okay. So specific humidity, we have to find W. So WBT is given, 24 degrees centigrade is WBT. PSAT is given 2 point, sorry, here. Okay, at WBT we have to find this PSAT. Okay, at WBT, PSAT equal to, we have to find, then WSAT equal to uh, this pressure difference times 2.98. So that is the PSAT. Okay. Yeah, I'll write it in another page. So, second question. At WBT, PSAT equal to, we have to find, then WSAT equal to 0.622 times PSAT by P minus PSAT. Okay, then W equal to, here calculate the same thing again. Next is RH value. PV equal to PSAT times 5 by 0.622 plus So PSAT you have to find it, dry bulb temperature. Okay. So RH equal to PV by PSAT. Next is density. P minus PV by R dry air times T plus PV by RW is water times T times RDA. Okay, sorry. So RDA equal to 287 joule per kilogram Kelvin. RW equal to 461 joule per kilogram Kelvin. And T equal to 309 Kelvin. These are the values. Then so we will be getting this dry air partial pressure. Then using that you have to calculate for density for dry air and density for water vapor. Then total density will be the sum of both of this. And the next question was specific enthalpy. Specific enthalpy also H equal to for individual species for dry air, H of dry air plus H of water vapor. Okay. Then room volume, we can calculate mass of dry air and water vapor in the room. So mass, if you want to calculate, density is already calculated. Density times room volume is mass of dry air, mass of air. Then due to measurement uncertainty, the wet bulb temperature is 24 plus or minus 1 degree. What will be the corresponding variation in humidity ratio and in relative humidity? Okay, so WBT uncertainty is plus or minus 1. So, so with WBT only, we'll be finding PSAT and then humidity ratio. So, so we have to take this plus or minus 1 and calculate for WBT equal to 23 and WBT equal to 25. And then take the difference, then you will be getting the variation. Okay. Next is a chamber at 101.325 kilopascal contains 10 kilogram of dry air at 10 degrees centigrade. 50 gram of dry saturated steam at 100 degrees centigrade is introduced into this chamber. This chamber is well insulated. Calculate the equilibrium condition, dry bulb and wet bulb temperature and relative humidity. Okay, so first steam is added and then the total mass of water vapor becomes initial plus this added weight. Then initial humidity ratio will be 0 because it's dry air only. And after adding steam, it will be like uh, the added steam weight divided by the total weight of dry air or initial weight. Okay. Then at 100 degree, steam is a saturated vapor. So enthalpy, so the pressure given is atmospheric pressure. That is why I'm saying it is saturated vapor. The enthalpy of steam, um, we can get it from the chart, and the process is adiabatic, so Q equal to 0. Energy balance will only have enthalpy terms, and mass of the terms are given. Specific enthalpy you can find from the chart, and yeah, from the chart you can find for the given temperatures. So total energy also can be calculated like that. Okay. Now for humidity ratio with for relative humidity, we can find from humidity ratio. Okay. Now fourth question. In an air conditioning system, room air is mixed adiabatically with outside air, 40 degrees centigrade and 25% relative humidity. Calculate the temperature and relative humidity of the mixture flow. Okay. So we have to find at 25. First, we have to find the mass flow rates. Then we need to find the densities, and then we can calculate the mass of the vapor and then the relative humidity. Okay, and that is how we have to approach it. So temperature again, it is from the enthalpy of room, room air and outside air. That difference, when it is mixed, then it will be a mixed enthalpy. We will be taking species by species, that according to the mole ratio we will be taking, and that is how we are finding the temperature. And the last question: during warm and humid conditions, such as those during monsoon, the evaporator of a room air conditioner has to cool humid air, and a substantial amount of water is precipitated out. The inflow rate of indoor air into the evaporator is 0.4 meter cube per second, and it is at 30 degrees centigrade and 65% relative humidity. The outlet air is at saturated state at 15 degrees centigrade. Calculate the temperature at which condensation commences, rate of water condensation, and the heat transfer rate in the evaporator. Okay, so everything is direct question only. So inflow is given, outflow is given, initial temperature, relative humidity is given. Now we have to find condensation temperature, that is dew point, water rate, and heat transfer. So dew point of incoming air we can find from PV equation. So Psat times 0.65, that is the relative humidity. So dew point temperature is where Psat is happening. So condensation temperature we can find it from the corresponding temperature of Psat. Then outflow is 15 degrees saturated. So moisture removed is W in minus W out. So W in equal to, we can find it from the data given, like pressure difference. So ambient pressure minus Psat times relative humidity, uh, yeah, relative humidity times Psat. If you're taking that, you'll be getting W in. W out also the same way. Psat temperature will be varying. That is the only difference. Then if you take the delta W, then you will be getting the moisture removed. Then mass flow rate of dry air, if you want to find, uh, that will be inflow volume uh, and density. If you multiply that, you will be getting the mass flow rate. Okay, so that's about it. Then heat transfer is Q equal to mass times delta H. So delta H, H in and H out. Previously also we have found the same. That is how we will be calculating. Okay, that's about week 11. Thank you.